So we're going to, in this video, look at factoring of the difference of two perfect squares. So the difference of two perfect squares is as follows. Oh, go away. Difference of two perfect squares. Factoring. So here is what the difference of two squares look like: a squared minus b squared. And this factors as a minus b, a plus b, or a plus b, a minus b. It doesn't really matter which you write first. So be very careful. It has got to be the difference of two perfect squares. Nothing else works. So for example, let's say we wanted to factor, and we said this was x squared minus 100. Now it's, these words are really important. It's got to be two, it's got to be perfect squares, right? And it's got to be the difference. So all those ingredients have got to be there. So we have two terms, 1, 2, and each of these is a perfect square. So in other words, this is x times x, and this is 10 times 10. And the reason it's interesting or important to identify those is, if you look back at this formula, this is a times a here and b times b, and what we use is a and b. See that? Not a squared and b squared in that. So you have to know sort of the ingredient that went to create that first term and the ingredient that went to create that second term. So in this example, my a would be x and b would be 10. So this would factor as x plus 10, x minus 10, and that's the end of it. Or you could have factored it as x minus 10, x plus 10. That makes no difference. So let's take a look at a few examples of this. So 64x squared minus 9. Again, do we have two perfect squares? So everything on the left end must be a perfect square, everything on the right end must be a perfect square, right? So 64 is 8 times 8, and x squared is x times x, and 9 is 3 times 3. So really what we have here is 8x times 8x if you move things around. So that indeed is a perfect square. So a is 8x and b is 3. So once we figured that out, then this is 8x minus 3, 8x plus 3. Let's take a look at another one. Let's say we had 49x squared minus 1. Right? Again, let's see if we can see if this is a perfect square. So 49 is 7 times 7, and x squared is x times x, and 1 is 1 times 1. So this is 7x times 7x, perfect square, and so a is 7x and b is 1. So we have 7x plus 1, 7x minus 1, and there we factored it. Okay. Be careful. So mistakes that people make, okay, is folks write, for example, they will see x squared plus 4, and they'll write that as x plus 2, x minus 2. That is not true. It has got to be a difference, not a plus. Okay, so it has got to be a difference or subtraction. So that would be incorrect. This cannot be factored by us. Don't forget, when you're factoring these two terms, the fact that there could be a GCF. So consider the problem 81x squared minus 9y squared. So in this particular problem, I can take out a 9 and get 9x squared minus y squared, like so. And now I can factor, I can I can look to see if this is a perfect square, and it is, right? After all, this is 3 times 3, x times x, y times y, or 3x times 3x, which is a equals 3x and b equals y. And so my problem factors is 9, 3x minus y, 3x plus 1. Okay, so don't forget the GCF step for factoring these things. Let's do one more, just an extreme example that we could see uh, of the difference of two squares, and that is this, p to the fourth minus 1. Now, is this the difference of two squares? Well, let's see. So to be perfect square, these must break apart equally. So I can think of that as p squared, and this is 1 and 1. So indeed, it is a perfect square difference. So p squared, p is 1, and so this factors as p squared minus 1 and p squared plus 1. Now the interesting thing about this problem is you're not done yet. If you look carefully at this one here, that in itself is a perfect square. That is p times p, and this is 1 times 1. So a is p and b is 1 for that. So that part of the problem works out as p plus 1, p minus 1. However, this part of the problem, it's not the difference of two perfect squares, so nothing there. So it just remains as p squared plus 1. So this is a pretty extreme case of this situation. We don't study the difference or the sum of cubes, so that part of the section is not for us.